Hello, my name is Kate Johns and I'm a maths teacher from England. I teach in a school called Chipping Campden Secondary School, which is for students aged 11 to 18. Our school is quite rural and the children come from lots of villages on the bus. We also have a farm at our school where we have sheep and pigs.
Welcome to Bhutan.
Thank you. Although I'm here on holiday, shall we do some maths today?
Yes.
Come and look at this prayer flag. See that green one there?
Yes, ma'am.
How tall do you think it is in metres? My height is 1.6 metres. How tall do you think the prayer flag is?
Almost 7.50.
7.50. Anyone else got a guess?
10 meters.
10 metres?
Maybe 8.
Maybe 8?
9.
9 maybe. Okay, I'm going to show you a way that we can make a good estimate of the height of that. Let's go outside and we can look at how we're going to do this. What I'm going to get you to do is to start at the bottom of the prayer flag and take a couple of steps, put your feet apart, bend over and look through between your legs until you can see the top of the prayer flag. If you can't see it, you need to take more steps and you keep going until you can just see the top of the prayer flag. Can you see it? Excellent, stand there. Okay, I need 2 volunteers with the tape measure. Chunku can now see the top of the flagpole when he bends over and looks through his legs. What you two are going to do is you're going to measure the distance from the bottom of the flagpole all the way to Chunku, and that will tell us how tall the flag is. Okay, come and stand where he is. Just there. Okay. And then don't hold the tape measure. Let go. Just stand there. And you come and start your tape measure again where he is standing. You move back. That's it. And then come up to this one. That's 10 meters so far. Right, you'll need to wind it in a bit now. Till it's straight to Chunku. 10 meters, 12 meters and 70 centimeters. Excellent. So the height of the flagpole is 12 meters and 70 centimeters. You can see we've measured the height based on the distance along the ground. The flagpole makes a right angle with the ground. You can see the flagpole from there. Excellent. So, 2 people are tape measure again. We've got different people this time, these 2? Pull the tape measure tight. Put it tight, that's it. And they're 5 meters. And then move up to him. There's 4 metres, so 9 metres,
7.
10 centimetres. So we've got 2 different answers. So we got 9 metres here and 10 centimetres. The previous one was 12 metres, a bit of a difference. Because the flagpole makes a 90-degree angle with the ground, when you're looking through your legs, you're looking at an angle of 45 degrees. If you've got a 90-degree angle and a 45-degree angle, the other angle in the triangle that we make must be how big? Who knows how many degrees there are in a triangle? Do you know?
45.
It's another 45 degrees because altogether the angles in the triangle add up to 180 degrees. So if we've got 2 45-degree angles, the one down here and the one up there, what type of triangle is it? An isosceles triangle, and that's where it's got 2 angles the same size and also 2 sides the same length. So this length here and the height of the flagpole will be the same, and that's why this method works. A more mathematical way of working out the height is to make a clinometer. It can measure an angle. We're only going to get it to measure an angle of 45 degrees, but we could make it measure any angle. We start off with a circle. How many degrees are there in a whole circle?
360.
360, excellent. And we want to get a 45-degree angle. So 360 degrees in a whole circle. We halve it, and then there's 180 degrees. We halve it again to get 90 degrees, and half of 90, 45 degrees. Okay, and what we're going to do is we're going to make a mark where that 45-degree fold is. What we then do is we stick a drinking straw on the top of the piece of card. Don't have the straw hanging out over the edge, because when you look through the straw you might poke your eye out. So we're going to stick the straw exactly on the top of the card. And then we're going to get a stone and a piece of string and tie the stone to the string, just so that it will keep the string straight and it won't blow in the wind because it's got a bit of weight on it. We're then going to stick the string exactly in the middle of the piece of card. We don't want too much sellotape this side because we want to be able to look through it and the string to move to the line for the 45 degrees. Okay, and what you're going to do this time, you're going to go out and you're going to lie on the ground and you're going to look through the straw to the top of the flagpole. If the string is on the 45-degree line, that's okay. If it's not, you might have to move further back or closer to the flagpole. So it would be good to work in twos, to be able, one to look to see if the string is there, one to look through the straw. When you get it so the string is exactly on the line for 45 degrees, you then measure the distance from the bottom of the flagpole to you. So we have the one that we've just made now and one that I made earlier. Would you like to have a go with one? And who would like to have a go with the other one? There we are. You'll both need somebody to help you to look to see if the string is on the 45-degree line. No. Get it much nearer to your eye. Yes, excellent. Who's got the tape measure? Can you come and measure this one? From here all the way to the flag. Put your end at this end, and you can be the 5-meter marker. And you go to the flag. Walk right up to him, that's it. And then you've got 2 meters 90. So you had 2 lots of 5 meters, 5 meters, and 2 meters 94. Do you know how much that is altogether? 12 meters 94 centimeters. So this is 2 meters 40, and you had 5 meters before. So 5 meters add 2 meters 40 is 7 meters and 40 centimeters. Okay, so the maths behind that. Here is our prayer flag. Here is the ground, and this is a 90-degree angle. If we join this up to make a triangle, this angle here was 45 degrees because we measured it on the clinometer, and we know that all 3 angles in the triangle add up to 180 degrees, so this must also be 45 degrees. 2 angles that are the same in the triangle means that it is an isosceles triangle, which means this side must also be the same length as this side. And that's why, by measuring the distance from the base of the prayer flag to where you were, will also tell us the height of the flag. Do you know the game rock, paper, scissors?
Yes, ma'am.
Yes? Is it a fair game?
Yes.
Why? Why is it fair?
It's fair because I think it is like for sharing or not.
It's sharing or not. Do you think about what the other person's going to choose when you play it? No, I don't. Shall we play it? If you two play against each other, you two play against each other, you two play against each other, and I'll play against you. We'll play 3 goes and see who wins. So you count 1, 2, and then the 3rd time you make rock, paper, or scissors. Okay, you two play against each other? Okay, are you ready? 1, 2, 3. You win. 1, 2, 3. 1, 2, 3. I win. So 1 each. Who won?
I won.
You won twice?
1, 2, 3.
Who won in yours?
He won.
He won. Who? 1-1. Yeah, we had that as well. Now, how do we know if it's a fair game? What we can use is a tree diagram. And we can represent this, what I do and what you do, as our different options. So here's me. When I do it, I go 1, 2, 3, and I can choose either rock, paper, or scissors. So I have 3 choices. Does anyone know the probability that I have of choosing rock? Nearly. It's something to do with 3, isn't it? Can you give me an answer in a fraction?
1/3.
1/3. Excellent. A third. I've got a third of a chance of choosing rock because there are 3 different choices and I have no preconceived idea what I'm going to choose. So what about the probability for choosing paper? Can you give me a fraction for that? 1/3 again. And for scissors? 1/3. If I add up 1/3, add 1/3, add 1/3, what does that come to? 3/3.
No, 3/9.
Not 3/9. 3/3. And what's that the same as? 1. Yeah. What? Just 1. 1 whole 1. Now it comes to your go. And if I chose rock, what could you choose?
Paper.
Yeah. What else could you choose? What else could you choose?
Rock.
Yeah, you've got 3 choices still because you don't know what I'm going to choose. And what's the probability of you choosing rock? Same as mine, yeah. A third each time. If I chose paper the first time, how many choices have you got for your go? 3, yeah. You could still have rock, paper, or scissors. And each one has a chance of a third of being chosen. And if I chose scissors the first time, you've got how many choices? 3.
Choice.
Yep. Rock, paper, or scissors, and each one has a probability of a third. Now, how many different combinations are there on this board? We could start off with me saying rock and you saying rock, and that counts as one combination. Can anyone work out how many different combinations there are?
9.
9. Excellent. How did you get 9?
Also, I've same like them. I've tried this rock to the other, but also, and afterwards I've tried with paper and scissors.
Brilliant. So you said, right, rock can go with rock, or rock with paper, or rock with scissors, and then you did the same with paper and rock, paper and paper, paper and scissors. And there we've got our 9 different outcomes. What fraction of a chance have we got of getting each of those?
1/9.
Yeah, 1/9. Excellent. Now 1/9 we can work out following the path through the tree diagram. Rock followed by rock. We've got 2 fractions there. 1/3 multiplied by 1/3 gives us 1/9. Each of these has a probability of 1/9. What do I get if I add all of those up? Because I get 1/9, 2/9, 3/9, 4/9, 5/9, 6/9, 7/9, 8/9, 9/9, and 9/9 is 1 whole. Now, where do I win? I'm the first one. Okay. Do I win when it's rock, rock? No. Do I win when it's rock, paper?
Yes. Oh yeah.
Do I?
No.
No. So I don't win there. I don't win there. Do I win when it's rock, scissors?
Yes.
Yes. Do I win if it's paper, rock?
Yes.
Yes. Do I win if it's paper, paper?
No.
No. Paper, scissors?
No.
No. Scissors, rock?
No.
Scissors, paper?
Yes.
Scissors, scissors?
No.
So what's the probability that I will win? 3/9, yeah. Now, what's the probability that you will win? So you're the second person. We know that I've won here. If it's rock, rock, do you win? No. If it's rock, paper, do you win? Yes. I'm going to put 2 ticks for you, okay? So we know the difference. If it's paper, paper, do you win? No. Paper, scissors?
Yes.
Yes. Scissors, rock? Yes, because the rock blunts the scissors. Scissors, scissors? No. So what's the probability that you will win? 3/9. And what happens here?
Draw.
It's a draw. So the probability that it's a draw is also 3/9. So it is a fair game because we both have the same chance of winning and we have the same chance of drawing as well.
Thank you very much.